In this video, we're going to kind of try and use another example of Monte Carlo simulation. And let's take an example for a trading scenario. Let's say one of my friend claims that if I trade rupees 1 lakh in Nifty every day, right, I can end the month with a likely return of 4% at the end of month, right? So that 1 lakh should basically become 1 lakh 4,000 at the end of the month. We find that the mean return on a daily basis is 0.05%. It's very minimal for Nifty, and annualized standard deviation is 16% for Nifty. How can we evaluate? What can we do to evaluate this claim, right? So we're going to do a Monte Carlo simulation for this as well, exactly similar to what we did in the previous video, an example around that. So let's understand what's given to us. It's being told that the mean return is 0.05 and the annual standard deviation is this. So I need to find the daily standard deviation, right? And daily standard deviation would be this into square root of, or sorry, this divided by square root of 250. That's because earlier we were taking daily and multiplying with the square root of 250. Now we are going to divide. That gives us the daily standard deviation, and that's approximately 1%. We invest 1 lakh rupees and we're going to do that for 30 days, right? So I have to do that for 30 days. And at the end of 30 days, my friend says that it is possible to be able to derive a certain value. I have to therefore ensure what return am I getting. The return that we are going to generate is going to be normally distributed with a random probability, right? Sorry, this is not norm dist, it's going to be norm inf, and probability is going to be the random number. Mean is given here to us, and standard deviation daily is what we have to take. So that's the expected daily return we are getting. And if this is the expected daily return, the portfolio value at the end of the first day would be equal to this much. And let's just format it and let's drag it down. Okay, sorry, we have to freeze B3 and B5. Otherwise, when I drag down the normal inverse function, it will create a problem, right? So we get this data and we can double click on this. So it just calculates the value based on the previous day's value. That's the daily returns we have simulated for 30 days based on the function normal inverse. And you end with 101,163 simulated. Your friend is saying that you have a chance of ending with a 1,04,000 kind of a number. So either I can do this 1,000 times, or as we did earlier, we're going to kind of try and simulate using a Monte Carlo simulation. So I'm going to put in 1, 2, 3, and probably drag this up ahead all the way down to 1,000. So let's put 1,000 iterations here, and that's done to 1,000. Then let's go up and link this cell to the last cell, and then select this entire thing, go to data, what if analysis, data table, nothing in row input cell. In column input cell, just point to any random column, click on OK, and we get the values. And just so that it's readable, I'm going to format all these values. That's the formatted value. Now, is the claim correct or not? I can find an average, and that average should tell me whether I will end with 1,04,000 or not. So the average is 1,01,532. It is not 1,04,000. And now whatever I try to do, I don't think the average will change materially from this 1,01,000 kind of a number. So if I trade on the Nifty every day, it's unlikely that at the end of the month I can end with a significantly higher value, unless some of these parameters change. Unless some of these parameters like the mean return, etc., change, the simulation basically tells me that on average, the value is going to be around 1 lakh 1,000, probably 200, 300 rupees above that approximately, right? That's the second case that we have seen on Monte Carlo simulation. That's it in this particular video.